In this video, we'll plot crime on a map of Chicago. First, we need to install and load two new packages, the Maps package and the ggmap package. So start by installing the package Maps. So type install.packages and then in quotes, Maps. When the Cranmere window pops up, go ahead and pick a location near you. When the package is done installing and you're back at the blinking cursor, also type install.packages and then in quotes ggmap. When that package is also done installing, load both packages using the library command. So type library maps and then library ggmap. Now let's load a map of Chicago into R. We can easily do this by using the getMap function. So we'll call it Chicago and then use the get_map function where the location equals Chicago and the zoom level is 11. Let's take a look at the map by using the ggmap function. Now in your R graphics window, you should see a geographical map of the city of Chicago. Now let's plot the first 100 motor vehicle thefts in our dataset on this map. To do this, we start by typing ggmap and then in parentheses Chicago. This is instead of using ggplot like we've been using in the previous videos. Then we want to add geom_point. And here we'll define our data set to be equal to motor vehicle thefts, where we'll take the first through 100th observations. And in our aesthetic, we'll define our x-axis to be the longitude of the points and our y-axis to be the latitude of the points. Now in your R graphics window, you should see the map of Chicago with black points marking where the first 100 motor vehicle thefts were. If we plotted all 190,000 motor vehicle thefts, we would just see a big black box, which wouldn't be helpful at all. We're more interested in whether or not an area has a high amount of crime. So let's round our latitude and longitude to 2 digits of accuracy and create a crime counts data frame for each area. We'll call it lat_long counts and use the as.data.frame function, run on the table that compares the latitude and longitude rounded to 2 digits of accuracy. So our first argument to table is round and then in parentheses MVT $longitude, 2. And our second argument is round and in parentheses MVT $latitude, 2. This gives us the total crimes at every point on a grid. Let's take a look at our data frame using the str function. We have 1,638 observations and 3 variables. The first 2 variables, var1 and var2, are the latitude and longitude coordinates, and the third variable is the number of motor vehicle thefts that occur in that area. Let's convert our longitude and latitude variables to numbers and call them lat and long. So first, we'll define the variable in our lat_long counts data frame called long and set that equal to as.numeric, run on as.character. Remember, this is how we convert a factor variable to a numerical variable, and we'll give the variable lat_long counts $var1. Now let's just repeat this for latitude. So lat_long counts $lat equals as.numeric, run on as.character, and then lat_long counts $var2. Now let's plot these points on our map, making the size and color of the points depend on the total number of motor vehicle thefts. So first, again, we type ggmap and then Chicago to load our map of Chicago, and then we'll add geom point, where our data again is lat, long, counts, and then in our aesthetic we have x equals long, y equals lat, and then the color equals frequency, and the size equals frequency. Now in our R graphics window, our plot should have a point for every area defined by our latitude and longitude areas, and the points have a size and color corresponding to the number of crimes in that area. So we can see that the lighter and larger points correspond to more motor vehicle thefts. This helps us see where in Chicago more crimes occur. If we want to change the color scheme, we can do that too by just hitting the up arrow in our R console and then adding scale underscore color underscore gradient, and then in parentheses low equals yellow in quotes and high equals red in quotes. If you hit enter, you should see the same plot as before, but this time the areas with more crime are closer to red and the areas with less crime are closer to yellow. We can also use geom tile to make something that looks more like a traditional heat map. To do this, we type ggmap and then Chicago, just like before, but now we're going to use geom tile, where our data frame again is lat, long, counts, and in our aesthetic we have that the x-axis is long, the y-axis is lat, and then we have alpha equals frequency. This will define how to scale the colors on the heat map according to the crime counts. Then close a parentheses and type a comma, and then type fill equals and then red in quotes, defining our color scheme. Close the parentheses and hit enter. This map takes a minute to load. While we're waiting, let's discuss what we've done in this video. We've created a geographical heat map, which in our case shows a visualization of the data, but it could also show the predictions of a model. Now that our heat map's loaded, let's take a look. In each area of Chicago, now that area is colored in red by the amount of crime there. This looks more like a map that people use for predictive policing. In the next video, we'll use data from the FBI to make a heat map on a map of the United States.